Hello class, in this lecture I will be talking about p-value. So this p-value is different from the p, which is population proportion, which we use in proportions. So p represents population proportions. So this p-value is different from that. So the meaning of p-value is probability that a sample will be in extremes or more than extremes of population. And this is mostly used to do hypothesis testing. And in statistics you will hear a lot that p-value less than alpha, you will reject your null hypothesis. So usually what it means is you are just looking at your normal distribution curve from extremes. So like if you have this curve which represents population, suppose we say we are doing a z-test, so this will be mean mu, and we do on a two-tail z alpha over 2 and z alpha, this is negative z alpha over 2 and this is positive alpha over 2, and this is our alpha over 2 and this was our alpha over 2, and we calculated like a test statistic by using formula z is equal to x bar minus mu over sigma by root n. So if this z value lies in these extremes, then the or somewhere here in this extreme, then if you see this probability is less than your alpha over 2. So if you see here, from here this space and this is alpha, this whole thing, and this is p over 2 and this is p over 2 on both sides. So if those values, p value is less than alpha, then you are saying you can reject null hypothesis because it lies on the extreme. So that's how you will be doing p-value calculations. So we will try to understand this problem by this concept by using a problem. Maybe in one tail also I will explain how it works. Suppose if I have a normal distribution curve and this represents mu and this is alpha, and you calculate z and it turns out to be you get z, and if your z value is somewhere here, you look at probability there. So obviously, and this is called p, so obviously p value is smaller than your alpha value, you can say you can reject h null. So that's how you are going to do these p-value problems. I will go and try to solve this problem, calculate the p-value and see what does it say. So I have an engineer, so an engineer has designed a valve that will regulate water pressure on an automobile engine. The valve was tested on 130 engines and the mean pressure was 6 pounds per square inch. Assume the population variance is 0.49. The engineer designed the valve such that it produces a mean pressure of 5.9 psi. It is assumed that the valve does not perform to the specification. A level of significance of 0.1 will be used. Find the p-value of the test statistic, round your answer. So again we are doing a hypothesis test and we'll calculate what is the p-value. So the first thing is I will note down what all is given. So 130 engines were tested. So my sample size is 130. The mean pressure of that 130 samples is 6. And then population variance. So they gave sigma square, which is 0.49. So we need, so this is known. When they said population variance, that means it's known. So our sigma will be 0.7, which is how do you calculate standard deviation from variance? You do square root. So this is sigma would be square root of 0.49, which is going to give you 0.7. And then we have the mu, the population mean. The engineer designed the value such that it produces a mean of mean pressure of 5.9. So mu is 5.9. So the next thing is we have to determine whether it is a it's a one-tail problem or a two-tail problem. So they say it is believed that the valve does not perform according to the specification. So if mu is 5.9 and if someone says it does not perform according to the specification, it might be generating less than 5.9 pressure or more than 5.9 pressure. So it's a two-tail problem. So two-tail. So we can evaluate both sides of a normal distribution curve. So let me write our hypothesis. So the first step of hypothesis testing is to define hypothesis. So when we define hypothesis, our null hypothesis is mu is equal to 5.9 and then alternative is mu not equal to 5.9. And then the second step of our hypothesis testing is compare test statistic with critical value. So that is how we were doing. So the test statistic the formula for test statistic. So which one we will be using, Z, T or proportions? This is a mean problem, so we will be using either of Z or T. So n is 130, so this is n greater than 30, and then your sigma is known, so this means we will be using Z stat. So the Z stat formula, Z is equal to x bar minus mu sigma over root n. So this will give us x bar is 6 minus mu is 5.9, or we can get from here, and then sigma is 0.7 over root n, which is square root of 130. So this is going to give us 1.62. So the next step would be to do critical value. So I will use a different color for critical value, maybe green. So I will calculate critical value here. So because this is a two-tail problem, I will plot it. So this will be our normal distribution curve, and I am looking for negative z alpha over 2 and positive z alpha over 2, and our significance level, let's see what significance level is given. So they gave us a significance level of 0.1. So our alpha is 0.1. So I will go, so significance level alpha is given as 0.01. I wanted alpha over 2. So alpha over 2 would be 0.01 over 2. That is okay, so this is 0.1. I'm sorry. Let me see what is it. 0.1. So this is 0.1. So this would be 0.1 over 2. So that is 0.05. So this area would be 0.05, and then this area would be 0.05, and this whole thing will be 0.90. So in this area the pressure valve is good, so you do not reject H null. And then in this region and this region you will be rejecting H null. So that is how you will be looking at in hypothesis testing, and then you kind of go and look for z alpha over 2, and then you look at those values and try to compare where does this z lie in a hypothesis testing. Because we are now doing p values, you don't have to calculate this z alpha over 2, negative z alpha over 2 and positive z alpha over 2. One of the ways you can do is to calculate p value. So how do you calculate p value? You go and look for where does what is the probability at z is equal to 1.62. So I'm looking for z is equal to 1.62 probability. So the other way is, because it gives us the left side of the curve, I can kind of look at maybe negative 1.62 z values. So negative 1.62. You can do anyways. So if you want to do negative 1 point, because positive 1.62 will lie somewhere on the right side, and then negative 1.62 will lie somewhere on the left side. So you are just looking, because I wanted normal, what's that, my table gives left side of the curve. I will look for negative 1.62 and see, because this is the extreme value, right? So I will try to look for negative 1.62. So I will go here and go to my in Canvas modules, look for go to calculation aids, and then go to statistical tables, download it, I will do enable editing, and then I'm currently in Poisson table. I will go and look for Z table. So Z table, you are looking for 1.62. Let me cross check if that is right. So I'm looking for maybe negative 1.62. So let's see what is negative 1.62. So negative 1.6 and then 2, the value would be 0.0526. So this value will be 0.0526. So since this is if you look at here, since this is 0.05 the probability, so 0.526 would be somewhere here, so it will be inside this line. So that means the probability is saying that you do not reject the region on one side. So if we look at on the other side, it will be the same. The probability of 0.0526 would be this whole area, so it's again falling on this. So you are looking at 0.0526 on both sides, so the p value would be 0.1052. So again, one of the easiest ways is if you calculate the p value, our p value is 0.1052. This is so we said if p value is less than alpha, we reject null hypothesis, H null. So if you see our p value is 0.1052, which is, and our alpha is 0.1, so this is clearly greater than, so we are not able to do not reject H null. That means as we discussed, it's this whole thing is, if you see, it's falling, it's kind of falling inside the, if you see these rejection critical values, it's falling inside do not reject region, the probability. So that's the reason why all these things is happening. So that's how you will be calculating p value. So this is the concept of p value. So I will go and kind of solve this using Minitabs. So one of the concepts I want you to remember here is p value less than alpha, reject null hypothesis. So this applies, this is constant and this applies everywhere. So now I will go to Minitab and get the p value. So if they ask you p value, I suggest you to use Minitab. That's the better way. So let me pull out my Minitab 19. Okay, so let me look at our data. So again, I will be taking values from this point to this point, everything. So the first thing Minitab asks us, so the first thing you have to go is to go to stats, go to basic stats, and then this is one sample Z test. So we will go to one sample Z, and then it's asking one or more samples in each column. We don't have any samples, we have a summarized data. So the first thing they are asking us is what is the sample size. So I will go here and look for the sample size. So the sample size here is 130, so I will enter that. Mm, 130, and then the sample mean is given as, let me check what is the sample mean. The sample mean x bar is given as 6, so I will do 6 here, and then known standard deviation. The standard deviation, known standard deviation in our problem is 0.7. So this is 0.7, and we wanted to perform hypothesis testing. So what is the hypothesized mean? So hypothesized mean is your mu, so that is 5.9, and then I will go and type in 5.9, and then you go to options, and then they will ask you what is the confidence interval. Our significance level is 0.1, so I will enter that. So 0.1 significance level means 99% confidence interval, so I will do 99%. And then alternative hypothesis. So what is your alternative hypothesis, they are asking you. So let's see, mean not equal to hypothesized mean. So our mu not equal to, right, this is hypothesized mean according to Minitab. So mean not equal to, so this is a two-tail problem, that's why we have not equal to. If it was a one-tail problem, it will be mu greater than or mu less than hypothesized mean. So all the three options will be available in Minitab. So if you look at the pop-up of this, you see you have mean less than hypothesized mean, mean not equal to hypothesized mean, mean greater than hypothesized mean. So at this time it's not equal to, so we will leave it like that. Click OK and click OK. So if you see, they gave us Z value, they gave us P value, which is 0.103. So this is the exact P value, and then they gave us so you can copy this 0.103. So one of the ways I suggest you to do P value is to use Minitab. So again, you can get confidence interval with Minitab. So this is 5.84 to 6.1. So you see the 6 mean, the 5.9 which is population mean, if you see, that lies within this confidence interval. That's why the other way to make analysis is you have sufficient evidence that the valve is operating at 5.9. So p-value here 0.103, so you can do that way through Minitab. 0.103, this is what Minitab says. So you can key in this number and it will be right. So that's how you will be calculating p-value. This concludes my lecture on p-value. Thank you.